Hello everyone, welcome to Organic Chemistry 2 Lab Experiment 1. Today we're going to do the bromination of transstillbene. The starting material for this experiment is transstillbene, the white crystals on weighing paper. The reactor for this reaction is a 50 ml conical flask. There is a tesseract bar inside this flask. Make sure you don't use the wrong glassware. A common mistake is some students may use an polymer flask as a reactor. If we put them together, we can see the major difference is this one has a ground glass joint on top, while the other one doesn't. Okay, so since today we're gonna use a condenser for reflux, the ground glass joint is required. Now I will make a funnel with a piece of weighing paper to transfer transstillbene into the reactor. With this funnel, your chemical will never be stuck on the neck of your flask. This is 10 ml of ethanol. Now I will transfer it into the flask. In this video, don't worry about any mass numbers or volume numbers because you will receive an email about all the data needed for your post-lab 1. Now I already put a condenser on the top of our reactor. Please keep in mind, the bottom is always the inlet of circulating water, and the top is always the outlet of circulating water. At this point, we can still see white crystals inside our flask. That means transstillbene is not dissolved in ethanol at room temperature. So we will heat it to increase the temperature. Turn the stirring. Turn on the heating. Power level 2.5 should be enough. Once transstillbene is fully dissolved, we will add pyridinium tribromide into our reaction. Now it's time to add pyridinium tribromide. This is already pre-weighed. To reflux the reaction, we need to increase the power level to 3.5. You don't want to start timing until you have observed the reflex. When it's reflexing, you can see solvent dripping down from the condenser. We will keep the reaction reflexing for 10 minutes. Now it's time to stop the reaction. We will first cool it to room temperature and then cool it in an ice bath. When cooling your flask in the ice bath, you want to scrunch the inner wall of your flask. This helps generate more crystals. The liquid in this test tube is methanol. I'm cooling some methanol because we need some ice-cold methanol for section filtration. Now we will do section filtration with a Buckner funnel. Make sure you have a piece of filter paper inside and you have the adapter here. Turn on the pump. First, I will add some ice-cold methanol. This makes the filter paper sticky to the funnel. And to the beginning, I'm transferring the material with a stirring rod. After you have transferred about half of your material, you can simply pour it. Now I'm using some ice-cold methanol to help transfer the material. And you can wash your crystals with some ice-cold methanol. Try to minimize the amount of methanol. If you use too much methanol, it decreases your yield. This is how the crude product looks like. We will keep it in the funnel with the pump on for about 5 minutes to make it dry. I will do recrystallization in this 50 ml beaker. I will weigh the empty beaker first, then transfer crystals into this beaker. Weigh it again to figure out the mass of our crude product. We need to know the mass of our crude product to figure out how much toluene is needed. Now we already have toluene and our crude product in a beaker. Since this is experiment 1, I want to explain what recrystallization is. Specifically, what we are going to do is, number 1, increase the temperature to fully dissolve all our crude product. Number 2, cool it to room temperature. Number 3, cool it in an ice bath. Number 4, collect the final product with suction filtration. Now I will start the stirring. And turn the heating. At this point, all our crude product is already fully dissolved. So we need to stop heating and cool it to room temperature. Now we're cooling it in an ice bath. The liquid in this test tube is still methanol, which is used for suction filtration. This is how the final product looks like. The next step is to figure out how much the mass is. Specifically, I will weigh this empty watch glass, transfer all our final product onto this watch glass and weigh it again to figure out the mass.